Now that we've demonstrated where the quotient rule comes from, I'd like to make use of it in a couple of examples. The number one thing that lets you know that you're going to use the quotient rule is when you see a quotient, a rational expression, one thing divided by another thing. So using the parlance of the quotient rule that we just derived, when I say f of x is equal to x squared minus 1 over x squared plus 1, the one on top is your high, and the one on bottom is your low. So once again, quotient rule states that this will be, using extra sets of parentheses anytime I need to group things together, low, d high, less, high, d low, over the square of what's below. Now the quotient rule doesn't finish all of the derivatives for you, but rather it gives you some more basic derivatives to work with. For example, we have an x squared plus 1 times derivative of x squared minus 1 is going to be 2x minus, parentheses, x squared minus 1 times derivative of x squared plus 1 will be 2x, and the denominator will remain the same. Now there's usually a temptation at this step of the process to say, oh look, we have an x squared plus 1 up here and an x squared plus 1 down here, and we should cancel one of those out. But because of the minus sign that we see right here, we really can't cancel those out at this point. Instead, I'm going to apply the distributive property a couple times in the numerator, and we'll see what we can simplify. Distributing the 2x in the first set of parentheses, that'll be 2x cubed plus 2x. Then distributing both this minus sign as well as this 2x, we'll see a minus 2x cubed and a plus 2x. Again, that comes from distributing the minus sign as well as the 2x. Now up in the numerator there are a couple of like terms that can be combined. The 2x cubed and minus 2x cubed will cancel. Positive 2x and positive 2x will become 4x. And the x squared plus 1 quantity squared will stay as it was. All set. Now, earlier in this section, we took the derivative of this expression by distributing the x cubed from the denominator to all three of the terms in the numerator, and then applying the power rule. I would like to demonstrate how we can also do this using the quotient rule, and we should arrive at the same conclusion. So with that in mind, we will apply our quotient rule. Quotient rule says low, d high, less, high, d low, over the square of what's below. Now again, quotient rule doesn't finish all of the derivatives for us, but it does give us some more basic things to differentiate. So we'll start here. X cubed times. Differentiating these three terms, 3x squared will give us 6x, minus 5x will give us minus 5, and plus 7 will become 0. Continuing along, minus 3x squared minus 5x plus 7 times the derivative of x cubed. That'll be 3x squared. And this is all over x cubed squared. X cubed squared would be x to the 6th power. Next, I'm going to distribute the x cubed to both of these terms, the 3x squared to all three of these terms, and we'll see what we can do algebraically. So I'm seeing 6x to the 4th minus 5x cubed. Distributing both the minus sign as well as the 3x squared, this will be minus 9x to the 4th power, plus 3 times 5, that's 15, x to the 3rd power, minus 3 times 7, that'll be minus 21, x squared. This is all still over x raised to the 6th power. Running a little low on space here, so I'm going to combine like terms over here. So I see 6x to the 4th minus 9x to the 4th. That'll be negative 3, x to the 4th. For x cubed, I see minus 5 of them here, plus 15 of them here. That'll be plus 10x cubed. And then we still have a leftover minus 21x squared. All still over x to the 6th. I notice that there is a common factor of x squared that I can pull out from the numerator. And if we pull that out with the intent of canceling that with what's in the denominator, we're going to start to see some familiar results. So this will be negative 3, sorry, that negative's in the wrong place, negative 3 x squared plus 10x minus 21 all over. When we reduce by x squared, that'll give us x to the 4th. Now to compare that to the results of the previous video, we can distribute this x to the 4th to all three of these terms and wind up with negative 3 x to the negative 2 plus 10 x to the negative 3 minus 21 x to the negative 4th. And fingers crossed, I'm really hoping that that's the same result as what we got the other way because, well, that's the way math is supposed to work.